It's the end of the second week in February 2025. Here's the science and space headlines we followed through the week. Varda's W2 mission progress report. Microgravity autonomous drug manufacture is here. Firefly Sparkle galaxy shines a light on early galaxy formation. And 2 new stars spotted dancing near the Milky Way's supermassive black hole.
21 years online. From Star Trek to science and space. And we're not stopping. This is Talkin' Science.
Detailed observations of a low-mass galaxy known as Firefly Sparkle that formed when the universe was around 600 million years old provides insights into early galaxy formation, according to international researchers. They've used the James Webb Space Telescope to study this early galaxy, while also observing 2 neighbouring galaxies, which they name Firefly Best Friend and Firefly New Best Friend, located at 6,000 and 40,000 light-years from Firefly Sparkle, respectively. They found that Firefly Sparkle is one of the lowest mass galaxies resolved into star clusters observed at cosmic dawn when galaxies were starting to form, with a mass similar to that of a progenitor Milky Way. The researchers say continued study of these galaxies can provide clues on how the Milky Way formed. First observed with the Hubble Space Telescope, new detailed observations from James Webb and presented by Lamia Mauler and colleagues shed further light on the galaxy's formation. The team used spectrometry and gravitational lensing, a phenomenon where a foreground massive object bends light from a distant source to estimate that the galaxy is located at a redshift of 8.3, placing Firefly Sparkle in the first 600 million years of the universe. They indicate the mass of Firefly Sparkle is concentrated in 10 clusters of stars with a total mass of approximately 10 million times that of our Sun. This makes Firefly Sparkle one of the lowest mass galaxies resolved into star clusters observed at cosmic dawn, and epoch when galaxies started to form with a mass similar to that of a progenitor Milky Way. NASA announced late last year it intends to award Blue Origin and SpaceX additional work under their existing contracts to develop landers that will deliver large pieces of equipment and infrastructure to the lunar surface. They expect to assign demonstration missions to these current human landing system providers to mature designs following the design certification review process. The American Space Agency plans for at least 2 delivery missions with large cargo. SpaceX's Starship cargo lander will deliver a pressurized rover currently in development by the Japan Aerospace Exploration Agency to the lunar surface no earlier than fiscal year 2032 in support of Artemis 7 and later missions. The agency expects Blue Origin to deliver a lunar surface habitat no earlier than fiscal year 2033. SpaceX will continue cargo lander development and prepare for the Starship cargo mission under Option B of the Next Step Appendix H contract. Blue Origin will conduct its cargo lander work and demonstration mission under Next Step Appendix P. NASA expects to issue an initial request for proposals to both companies early this year. There's a pioneering effort to replace the risks associated with in-orbit manufacturing of drugs that's about to touch down in South Australia after a second round of production in orbit. Varda Space Industries is currently in its second round of production following the successful W1 mission last year that returned to Earth in Utah. This time, they're aiming for the Kaniba test range with the next evolution of manufacturing in orbit.
For Varda, I think there's 2 main things that set us a little bit apart from the ISS-based human-rated research. So the first is that all of our manufacturing is actually completely autonomous. And what that means is there are no humans in the loop. You don't need a person kind of cramped inside of a capsule or a space station mixing any sort of drug or doing any sort of formulation. We actually make a very complex set of electromechanical fixtures and machines and motors and valves to be able to do all that for us. And so while we do have operators and mission control on the ground that initiate these sequences, there are no people involved in space doing it, which is great for a couple of reasons in terms of spacecraft autonomy, as well as exposure to drugs and potential dangers there.
The W2 capsule carries payloads from Varda partners, including a spectrometer from the Air Force Research Laboratory, and employs a heat shield with a thermal protection system developed in collaboration with NASA's Ames Research Center. These payloads are in addition to Varda's expanded pharmaceutical reactor. It launched aboard a Falcon 9 transporter mission on the 14th of January 2025 and will come back to the Kaniba test range in the next few weeks. A new paper published in Nature has revealed an international team has identified 3 ultramassive galaxies, nearly as massive as the Milky Way, already in place within the first billion years after the Big Bang. This surprising discovery was made by the James Webb Space Telescope's FRESCO program, which uses the NIRCam Gruesome spectrograph to measure accurate distances and stellar masses of galaxies. In the hierarchical model of galaxy formation, galaxies form gradually within large halos of dark matter. Dark matter halos capture gas, that's atoms and molecules, into gravitationally bound structures where stars are formed. Typically, only 20% of this gas is converted into stars in galaxies, but these findings challenge that view, revealing that massive galaxies in the early universe may have been much more efficient in building stars than their later counterparts, growing much more rapidly than previously thought. And while most sources found in the FRESCO survey fit existing models, scientists found 3 surprisingly massive galaxies with stellar masses comparable to today's Milky Way. They've been named red monsters due to their high dust content, which gives them a distinct red appearance in the JWST images. Associate Professor Ivo Labby from the Swinburne University of Technology says these findings raise new questions for galaxy formation theories, specifically the issue of too massive galaxies in the early universe, noting that current models fail to explain how it is possible star formation is so super efficient very early in the universe. 2 new stars have been found dancing near the Milky Way's supermassive black hole, according to international researchers who say the binary star system was predicted to be there but has escaped detection until now. The team found the stars by looking at archival data from the Very Large Telescope and the Keck telescope. The binary system, which is 2 stars held together by gravity and dancing around a common point, is called D9 and is relatively young at only 2.7 million years old. Sagittarius A, the formal name for the centre of our galaxy, is orbited by high-velocity stars and dusty objects, which are known collectively as the S cluster. Florian Peska from the University of Cologne's Institute for Astrophysics and colleagues studied the archival data and found D9 within that cluster. Its relatively youthful age indicates that they likely formed outside of the S cluster though. Further analysis suggests that this system is reaching the end of its stable window within the S cluster and that the 2 parts of the binary system could merge in the relatively near future due to the influence of the black hole. The detection of D9 suggests that these binary systems are capable of residing within the S cluster for approximately 1 million years following migration from outside. These findings provide new insights into one potential evolutionary path of stars in the orbit of Sagittarius A. Well, that's a wrap on the second week in February 2025. I'll be back for more Talk and Science Daily Bites in YouTube Shorts on TikTok, Facebook, Instagram and LinkedIn. Find us, like, follow and subscribe. Become a member too to get early access to our Monday deep dives or whenever they happen during the week. It's all part of our 2025 commitment to bringing you science and space news and views with an Aussie flair.